In this lesson, we will discuss how to store and load configuration settings for your application from a configuration file. In this section, we will describe the different approaches for loading configuration settings for an application. Configuration settings include any values that must be set before an application can run correctly. These values can include hardware configuration, file paths, default UI values, and default state data, and any other values that you might want to set in an initialization case. Depending on the value, you may only need to set the configuration once, or you might need to change the value based on a state change or user input. If you only need to read configuration values once, you might use constants on the diagram to set them once, either outside of a loop or in an initialized state. This approach has the benefits of being quick and easy to implement. It also abstracts those values away from the end user. On the downside, this static approach runs into challenges if you come back later and need to modify the constant values. For example, later on, you might need to use different hardware or want to log to a different file. If you set the values in multiple locations based on different states, then you will have to change the values in each location. If you want to change the value while the code is running, you will have to stop the application, change the constant value, and then rerun it. For some configuration values, you might want for the user to set the values before running the VI, or allow the user to change them while the code is running. To do this, you can create controls on the panel. This approach has the benefit of being dynamic and enabling the user to change the configuration values while the VI is running. On the downside, this approach can result in a very cluttered UI, depending on the number of settings and controls that you use. Additionally, since you are allowing the user to modify these settings, there is the risk of the user entering incorrect settings. As an alternative to using diagram constants or panel controls, you can use a file to store configuration settings. This file can serve as a single location to set and modify all the configuration settings for your application. If you need to update values between executions, you can modify the file instead of having to search for constant values on a VI diagram to replace. By defining these values in a file, you can ensure that any settings that are dependent on each other, for a specific piece of hardware for example, are loaded together, reducing the chance of user error. If a value is used in more than one location in your application, you can read the value twice, eliminating the risk of changing a value in one location but forgetting to change it in another. An additional benefit to reading configuration data from a file is that you can easily switch between different configuration files. Each file can contain all of the appropriate settings for a given scenario or hardware setup. You can create one file that contains the default values for the application and use a file path control or file dialog node to enable the end user to choose a different file. Examples of file formats that can store configuration data include delimited files and INI files. In this section, we will discuss how to load configuration from a delimited file. A delimited file is a text file that uses some special character to separate columns of data. A tab delimited file uses tabs to separate data, and typically has a txt file extension. A comma-separated file uses commas to separate data, and typically has a txt or CSV file extension. Use the delimited spreadsheet nodes to communicate with the delimited file. To store configuration data, you can use a single write delimited spreadsheet node with a 2D array of strings to write the configuration data to a delimited file. In this example, a tab constant is wired to the delimiter input of the write delimited spreadsheet node. Loading configuration data from a file is where we start to see the challenges with this approach. We can read the configuration data from the file by using the read delimited spreadsheet node, but we must then index the resulting 2D array to extract the specific information that we want. Once we extract that information, we must then convert it to the appropriate data type. If you update the file to contain a new piece of information in the second row, how would you need to update this VI? You will need to update this VI so that the row input to each index array node is 1 greater. If you want to read the new data, you will need to add a new index array node that reads from the new row. If you want to search the 2D string array for the value of a specific configuration setting, otherwise known as a key, you can search for which row in column 0 contains the key name, and then return the corresponding key value in that row in column 1. For example, if you want to know the value of sample rate, the index array node will return all the key names in column 0. And the search 1D array node will search for the key name sample rate and find it in row 2. Then we will use the index array node to return the key value in row 2, column 1, which contains the key value of 1000. A tab or comma delimited file enables you to store configuration data for later extraction and use in your application. This approach has the benefit of being relatively easy to write and read the file contents as a whole. The downside is that this approach requires you to develop custom code to extract specific values from the file. The data will be read as a string, so you will need to convert it if you need to use it as a numeric. If you don't know the specific row or column for the value, you must implement custom code to search the 2D string array. In this section, we will discuss how to load configuration settings from an INI file. Initialization, or INI files, use a predefined format to store values. To create, read, or modify an INI file, use the nodes found in the configuration file palette. An INI file has a defined structure. A section is a group of related configuration settings, otherwise known as keys. This INI file has an analog input section and an analog output section. Here, we see the keys in the INI file. Each key has a name and a value. In this INI file, there are 4 keys. The key name samples per channel has a value of 1000. This example VI writes one key value to an INI file using the write key node. In order to write a value to an INI file, you must specify the section, the key, and the value that you want to write. The write key node will automatically adapt based on the data type of the value input wire. In this example, the write key node adapts when a DBL data type is wired to its value input, and then provides additional precision and format inputs. We're able to specify the format and precision to determine how to format the DBL into a string to write to the INI file. The code to read data from an INI file is very similar to the code that you use to write that data to the file, except we use the read key node. For each key value that you want to read, you must first specify the section that you want to read the value from, and then the key name that you want to read from that section. The read key node reads a value associated with a key in a specified section in the INI configuration file. If the key does not exist, the node returns the default value for that value output and returns false for the found output. Also, in the Item tab, you can configure what data type you want the return key value to be in LabVIEW NXG. In this example, the read key node is configured to be returned as a DBL data type. An INI file enables you to store and load configuration data for your application. This approach has the benefit of being easy to write and read configuration settings and organize them into sections. The write key and read key nodes also conveniently have built-in data type conversion and configuration. The downside is that this approach requires you to use one write key node for every key you want to write, and one read key node for every key you want to read. Let's take a look at an example of loading and storing configuration in an INI file. First, let's take a look at the write config data VI. This VI starts by generating a file path and sending it to the open config data node. Then we have a separate write key node for each key to write to file. For each write key node, we specify the section, key name, and key value. The write key node will automatically adapt based on the data type of the value input wire. For example, the string input here made this one a write key string node. The DBL input here made this one a write key double node, which provides additional precision and format inputs. The I32 input here made this one a write key I32 node. Lastly, we use a close config data node to close the file. Running this VI will generate this INI file. Now, let's take a look at the read config data VI. We pass each read key node a section and key name. And the read key node returns the key value. Notice that I can go to the Item tab and specify the data type for the return key value. use this as a sub-BI to read configuration values in an application. When used as a sub-BI, the configuration file path will be an input, and the returned key values will be outputs. This application starts with the initialize state, which checks if there is a default .ini file in the same directory as the LV project file. If so, it uses the read config data sub-VI to return all the configuration values from the ini file, which then are stored in the ship register. So now all states have access to the configuration values. If a default .ini file does not exist, the application will just use its own default configuration values from this initialized ship register constant. When running this application, if the user clicks the Select Config File button, the application will go to the Select Config File Value Changed event case, which will give the user a file dialog to choose an ini file, and then reads the configuration values from the ini file, and stores those values into the ship register.
Good. चलो देखते हैं. वैसे पूछ रहा था.
You've completed this module. Here is a summary of what you've learned.